Okay, so today we're going to do, basically it's a linear inequality story problem. Linear inequality story problem. But the name of the problems are called linear programming. So that's a little bit different, but it's a linear inequality story problem. So these are always like big paragraph problems, but if you just read them, you'll kind of get it. So the tennis rackets make two types of rackets. Oversized and standard. Oversized and standard. So we would just say X is the oversized. So we've got two types of rackets, oversized and standard. And really we could be more specific if we wanted. We could say number of oversized rackets, number of standard rackets, right? And then they're going to give us these constraints. They say the oversized is between 10 and 30. So that means 10 is less than or equal to X is less than or equal to 30. And the standard rackets is between 30 and 80. So 30 is less than or equal to Y is less than or equal to 80. And then it says the total number of rackets should not exceed 80 per day. So X plus Y is less than or equal to 80. Okay, so now we're going to have to graph these, but before we get to that, I'll do the last part, which is what we call the profit equation. Anything with money is going to go over here, so I call this the profit or the money equation. So we get $15 for each oversized racket, $8 for each standard racket. Okay, so now we've got to graph this. Okay, so when we graph it, we've got to decide our scale, right? We got to decide our scale. So usually it works to count by tens. So I'm going to count by tens. Let me do these in the colors. So the X is between 10 and 30. So, and I like to write down what I'm counting by. So count by tens. So the X is between 10 and 30. So trying to keep it as straight as possible. I am sad to say that I hit pause and forgot to start again. So just to show you, like it happens to the best of us, I have to erase everything I've done here. Everything I've done. I might keep that part and redo it. Oh, don't you hate that? That's the worst. So I'll start again. It's fine, right? What's the big deal? So we're now graphing the constraints. So I was graphing that X was between 10 and 30. And then it said Y was between 30 and 80, I believe. So there's 30, 40, 50, 60, 70. There's 80. So far I've got kind of this rectangle area. But I still have to do the X plus Y is less, or Y is less than or equal to negative X plus 80, right? I just solved that for Y. So I'm going to do my Y-intercept of 80, and then down 1 over 1, down 1 over 1, down 1 over 1. So this gives me less than or equal to this shape right here. This is my polygon, if you were. And then I'm going to identify the 1, 2, 3, 4 corners of that polygon. So now we have our ordered pairs, right? And I saved them from before, so I've got them here. And 1030, 1070, 3030, 3050. It doesn't matter what order you put those in, and we're always going to have the same number of boxes for you as ordered pairs that there are. And so then we're going to plug it in here. So 15 times 10 plus 8 times 30. You don't have to show that. You can just do that on a calculator. So what is that? 150 plus 240, I believe is 390. 150 plus 240, right? Yeah, 390. And that's money, so we're going to leave it like that. And then similarly, we would do 15 times 10 plus 8 times 70. Again, you don't have to show that work. That would be 710. This one works out to be 690, and this one works out to be 850. Then to finish it all out, to bring it all home, you look for the maximum. In other words, the biggest number in that column, which is 850. And then your answer, we're kind of picky. We want you to go back to what these things stand for. So the 30, 50 means 30 oversize and 50 standard. And the total number of money you would make, profit, is $850. And that is all part of your answer. So it is just one giant story problem on linear inequalities. And we give points for like every single part, right? So you only have one of these on the test and you get points for everything.